Hello, everyone, and welcome back to class. Well, we are now in the home stretch of the course, and we're going to start learning about our last focus of science, which is going to be physics. I like to open up with a quote. When you change the way you look at things, the things you look at change. And that is from the father of quantum physics, Max Planck. This is a really inspiring quote because what we want to do in this unit, this last hill in the class, is start to be able to understand physics and its relationship to the other sciences. Because behind all the sciences we have covered, there's at least a little bit of physics stored away, and that we need to kinetically express that to our learners and use science as a vehicle for conversation and learning. Physics tends to scare off a lot of college students and also educators. And what we're going to be doing in this unit is be able to get rid of that complex mathematics that most think about when physics comes to mind. And we want to be able to cultivate the mechanical nature behind it and the conceptual. Because a lot of the physics that can be experienced and communicated to your learners will actually be done just through observations and hypotheses. For an example, in physics, we want to be able to communicate, such as you have a flat plane or surface, and how does a car move across that flat surface? How does it displace along and say an x-axis on a graph? And slope becomes changed. Physics helps explain that. When we look at a Slinky, which is one of my favorite toys when I was little, how does it work when it's compressed and when it's relaxed? If I move the Slinky left and right, you'll notice longitudinal waves. It's the same wave behavior that my vocal cords, as they vibrate, are emitting sound. So that way you can hear what I'm saying in this recording. Physics also helps explain momentum and the behavior of collisions from stored energy, as seen in this perpetual motion model, to where I bring the clacker back, and you'll notice the transference of energy from the left to the right. As you have momentum and collisions, you're also, again, experiencing waves that produce sound, much like the waves you would encounter at the beach. Light, seen right here, is just another type of wave, the expression of energy, which physics allows us to be able to communicate this idea with as a medium. So to take it all the way back, what we're going to be doing is taking these ideas in physics and connecting you to them, so that way you can connect to your learners about these topics. And the previous sciences that we've encountered so far have just a little bit of physics behind them, such as the plate tectonic motions that our continents go through. There's physics behind it, momentum and collisions. Even when we look at the night sky, the bright stars and planets, or even during the daytime with the sun, are all emitting different types of energy that we can go and experience. And we'll encounter more about that later in the class. Even the orbits and the rotation of our planet is all guided by physics. So this week, we are going to be, again, working on this topic. In lecture, you're going to have a continuation of the reflection of pedagogy assignment that we covered last week. Remember how we did universal course design? Well, now we are going to improve on those ideas that you had come up with last week. In lecture, we're going to learn about sound waves, as they are one of the more easier to understand and communicate with, because they are much more vibrant. And in fact, a lot of the music that we listen to is just combinations of different types of sound waves. But it's the vibrations behind them that actually should be more interesting to you. Then in lab, we are going to do a simulator where you're going to examine waves such as those you encounter, say, at the beach, again, because wave behavior is generally the same throughout water, sound, and even light. And then you're also going to be constructing a rubber band box. And it's going to be kind of like a musical instrument where you're going to have a box, put some rubber bands onto it, and then check to see how they vibrate. Are they producing certain sounds, or are they not? And then we're going to craft our hypotheses around that vibration. So that way our learners can understand that anything can produce a wave, and a wave is linked to physics. If you have any questions, I'll be happy to help out. Again, you can reach me during my open office hours for tutoring. If you want to be able to come in, just talk more about science, I'm there. You can reach me on email and, of course, on Zoom. Thank you. This is Professor Van Vranken. Thank you, and have an excellent day on planet Earth, and keep up the good work.